Alright, so we have a box of weight 30 newtons that is on rest on a horizontal surface. If the coefficient of static friction between the box and the surface is 0.5, we want to know what horizontal force must be applied to get it to start moving. Alright, so since it's asking about how much force is needed to apply to the box to get it moving, we should sum forces on the box. So for step 1, we're going to say the box. Alright, so in step 2, we need to start identifying our forces. So the box has weight, so we're going to have a force due to gravity in the negative y direction. It's on rest on a horizontal surface. This tells us that we have a force normal in the positive y direction because the surface is in the x, so remember normal means 90 degrees, so it must be 90 degrees or in the positive y direction. We're then told that there is a coefficient of static friction. So if there's a coefficient of static friction, there must be a force due to friction. And since we're trying to get it to start moving, that tells us we're at rest, so we're going to use a force due to static friction. And I don't specify what direction the object is being pushed in. So I'm going to say the object's being pushed in the positive x, so friction's in the negative x. You could do the opposite as long as they're opposite to each other. And we're being asked what the force applied is, so that means that there must be a force applied. So since I said friction was in the negative x, say force applied is in the positive x. Alright, so let's draw our free body diagram here. So step 3, so we have force normal in the positive y, force of gravity in the negative y, force applied in the positive x, and then force due to friction static in the negative x. Nothing has to be broken into components, so we can move on to our next step. So step 4 is to write Newton's second law in the x direction. So we have force applied minus the force of friction static is equal to mass times acceleration in the x. And then in the y direction we have force normal minus force of gravity equals mass times acceleration in the y. Alright, so now we can solve for the force applied. The force applied is in my x direction equation. So let's start with the x direction equation. So we're just trying to apply enough force to get it to start moving. So that means we're initially at rest. So our acceleration in the x is at 0. So force applied minus force of friction static equals 0. Or force applied equals the force due to friction static. So if we can figure out what our force due to friction static is, we can find what the force applied is. So we can't go any further with this, so let's look at our y direction equation. So we don't know the force normal. So force due to gravity, we're given 30 newtons, so we're given the weight in the problem. So remember, weight is the scalar term for the force due to gravity, so I can just sub that in. And acceleration is going to be 0 again, because we're not bouncing the box up and down. So we can say force normal minus 30 newtons equals 0, or that the force normal is equal to 30 newtons. So we learned in this particular section that the force due to friction static is less than or equal to the coefficient of static friction times the force normal. Since we're trying to find the minimum force that has to be applied, we want to find the maximum static friction. So we would say the force due to static friction is equal to the coefficient times the force normal. We're given the coefficient in the problem, and we just found the force normal. So we can say the force due to friction static is 0.5 times 30, or 15 newtons. We can then take that 15 newtons and plug it up back here and find that the force applied is equal to 15 newtons.